Hello, friends. Welcome back, and thank you for tuning in again. I want us to continue with the curve sketching. If you followed in my previous uh, video, I talked about curve sketching using or where a quadratic function was involved. Now, in this video, I want us to look at the other scenario where we have a cubic function. The cubic function we mean is a function of this nature. Is a polynomial of order 3. The highest power is 3. So again, as we had said earlier, we need to find, and I want to go direct, the salient features. So the first one will be the y-intercept. Let's look at y-intercept. You could start with any y-intercept. Could either start with the y-intercept or x-intercept. There's no rule of starting which to start with and which not to start with. The idea is to get them, so it doesn't matter which comes before the other. So here we have at the y-intercept, you remember the value of x is equal to 0. So we substitute in this equation. So you can see if x is equal to 0, then our y will be, we substitute 0 here. So 2x cubed. So 2 times and x cubed, 0 cubed is just 0. So that's 2 times 0, which is 0. Then we have 9x squared. Substitute for 0 in place of x. You'll have 9 times 0, which is 0. So 0, 0. Then 10 times 0, so 0. So we remain with negative 3. So this is the y-intercept. Now the next thing we need to look for is the x-intercept. Now again at x-intercept, now here the value, it's the value of y that will be equal to 0. So therefore we equate this function to 0, which is at x-intercept we'll have 2x cubed minus 9x squared plus 10x minus 3 is equal to 0. So the task that we have is of solving this equation here, cubic function. Now I charge you with that responsibility. You can do factorization of this. You can use factorization method. When this expression here, cubic function here is factorized, you can do that later to confirm what I'm just saying. It can be factorized and it reduces to x minus 3 multiplied by 2x squared minus 3x plus 1. Now this is equal to 0. So we have that is equal to 0, and we have written it in this other form by factorizing it. Now when we have it this way, we have two brackets. When multiplied you get 0, then it means that either one of the brackets, for instance, is equal to 0, and therefore in this case x will be equal to 0, or the other bracket 2x squared minus 3x plus 1 is equal to 0. Now this here is a quadratic equation that we can solve to get the values of x. So remember we already have one of the values of x, so this bracket, what we had there, is also equal to 0. So we solve it, and if we solve this, again I'll ask you to use any convenient method to you, be it graphical or factorization method. You'll realize that this equation has solutions of x is equal to 3 or x, sorry, this one was, this x minus 3 is equal to 0, so x is 3. Sorry for that mispronunciation. This is not x is equal to 0, it's x is equal to 3. Now when you solve this, you'll have x is equal to 1 or x is equal to a half, or x is equal to a half when you solve that other equation. Now, so now here we have 3 x-intercept. So what we are saying from our calculation is that x-intercept is at x is equal to 1, x is equal to 3, and x is equal to a half from our calculations here. So we have the 2, the y-intercept, the x-intercept. Again, if you remember, the next thing that we now need to know is the turning point. So, and to get the turning point, or points, if there are more, that will depend on the outcome of our calculation. We carry out differentiation of the function that you have here. So we'll use differentiation, that's in calculus. So we find the derivative, or what we call differentiation. Now in this case, our function, this is our function as we were given. So the derivative, which is written as dy dx, which can also be denoted by y prime. So dy dx, if you check again your differentiation, so if our function is as what we have there, then the differentiation will be 6x squared minus 18x plus 10. Now, after finding the differentiation, now we equate this to 0, because at turning point, so the reason is, that is, we are saying because at turning point dy dx is equal to 0. So our aim here is to find the value of x when the gradient is 0, when dy dx is 0. So we come to solve this equation that we've gotten from the differentiation. This equation is called a gradient function equated to 0, and we equate to 0 because at turning point dy dx is equal to 0. Now you can see here this equation, there's a common factor. We can solve it as it is, or we can also simplify it by dividing through by common factor first, just to make it a simple equation. So if I divide through by 2, 2 is common to all the 3 terms, including 0. So we'll have 3x squared minus 9x plus 5 is equal to 0. I was just simplifying the equation, not changing the meaning. Then we solve this, which when we solve, again, I'll charge you with the responsibility of solving this. These are another quadratic equation. You can use any appropriate method that is convenient with you. Quadratic formula, completing square method, or even factorization method if you can factorize. So when you solve this, you'll find that x, when this is solved, you'll find that the value of x is 2.3, or x is 0.7 when rounded off, 0.7. Now these are the values of x at the point where the gradient or the turning point at where the gradient is 0. That is at the turning point. So in order to get the coordinates, we'll use these values in the function that we had to get the corresponding y values, and then we shall know the turning points. So in this case, so if, for example, now you'll allow me to round off this to the nearest whole number. So if x is equal to 2, I'm taking 2.3 as 2, then y will be substituted in our equation that we were given, will be y will be 2x cubed, which is now 2 cubed, and then minus 9x cubed, which is 2 cubed, 2 squared, 9x squared, and then plus 10x, which is 10 times 2, then minus 3. When you work out this, you'll have, this is 8 times 2, which is 16. 16 minus 36, because this is 9 times 4, 36. And then plus 20 minus 3. Now when you work out this is negative 20. Negative 20 plus 20 is 0, and then 0 minus this. So we have negative 3. The value of y is negative 3 when x is 2. So that means one of the turning points is at, that is the turning point is at, that is one of them, 2, negative 3. And then the other one will substitute the value of 0.7 of x, which is 0.7, into the same equation to get the corresponding y value. So in that case, so when x is equal to 0.7, then you'll find, again, I'll ask you to substitute, and you'll find that the value of y will be at approximately 0.3 when rounded off to the nearest whole number. So the turning points are at 2, negative 3, and at 0.7, 0.3. So we have, in this case, you can see we have two turning points. We have two turning points that emanated from the solution of x from the derivative. When we derived and then solved for x, we got two values. And remember, the derivative equated to 0 gives us the turning point. So it means we have two turning points. And the turning points are at 2, negative 3, and 0.73. Now, finally, the next, even before we reach the final stage now of sketching, we said after identifying the turning points, we need to know the nature of the turning point. So by nature, we mean whether it is a maximum or a minimum. Maximum when it is curving downwards, and minimum when it's curving upwards. So here we have 2 points. We need to test only one, and the other one will be obvious. Notice that in this case, we expect this curve to be either this way, so that it will have one maximum. If one is maximum, the other one must be a minimum, or it will be this way. So if one is a minimum, the other one must be a maximum. So in our case here, we have 2 points. We only need to prove one or to tell one, and then the other one will be obvious. So if we, for instance, choose this one of 2, negative 3. So how do we tell the nature of the turning point? To tell the nature of the turning point, we first of all get the second derivative, that is y double prime. Remember, when we are getting the turning points, we took the first derivative. So the second derivative is actually the differentiation, the derivative of the first derivative, okay, which we reduce to this, we simplify to this. So what is in this case, the second derivative will be 6, you can see is 6 x now minus 9, because you remember it was 3x squared minus 9x plus 5. So when you differentiate this, you'll get 6x squared, then minus 9. Then, now this is the second derivative. So what we need to do is take the value of x. Remember, we want to tell, I've chosen this turning point negative 2, negative 3. So we want to tell the nature of this turning point 2, negative 3. So what do? We take the value of x at that point. Now in this case, the value of x is 2, and substitute in this second derivative. So like in this case, it will be 6 times 2 minus 9. And what do we have there? It is 3. That is 12 minus 9, which is 3. Now once we do this, we are to ask ourselves this question. After substituting or after getting the final value of the second derivative, we ask ourselves, is it a positive or a negative? Now, it doesn't matter what the value is. What we are interested in at this stage is whether it is a positive number or a negative number. Now, if it is positive, if the second derivative is positive, then the turning point is, if it's positive, the turning point is a minimum. That means it's curving upwards. And obviously, now when if it's the value is negative, remember we are not interested in the value itself. We're only interested in the positivity or negativity. If it's negative, then the turning point is a maximum. That means it's curving downwards. Now in our case here, you can see our derivative is positive. So what do you think? These 2, 3, which turning point is it? What is its nature? If the derivative is 3, you are correct. It is a minimum, because we've said for second derivative, if it is positive, the turning point is a minimum. Now that means, therefore, that the other turning point is a maximum. So we don't even need to prove. Okay? If a curve has 2 points, 2 turning points, and one is a maximum, the other one will be a minimum, and vice versa. So finally, we go to our graph, our sketch. Again, you have our Cartesian plane. Okay. So we need the salient features, the x-intercepts. Remember, we talked about x-intercept being at 1, 3.5. So you come and indicate here. So if this is, let's say this is 1, 2, and 3. So if this is 1, 2, and 3, then at x-intercept is at a half, somewhere here. At 1, remember we said 1, and at 3. Okay. And then we said our y-intercept, remember our y-intercept is at -3, as we had said earlier there. So we come and check where -3 is. -3 will definitely be on the lower side. So you indicate -3. So that's where I intercept. Now the other thing now we need to know are the turning points, and we've seen the turning points are at 0.7, 0.3. So 0.7 will be somewhere before 1, and 0.3 will be slightly above, assuming this is where our 1 is. So 0.3 will be somewhere here. Now you said that, and then the other turning point is 2, 3. Now we said that the turning point 2, 3, which we inspected here, was a maximum. So it means the other one is was a minimum. Sorry, because it was positive. So the other one is a maximum. So it means maximum. So you come and indicate here. Just show curving upwards. Maximum is something that is curving downwards this way. So you indicate there. Then the other turning point is 2, -3. 2, -3 would be somewhere here. Okay, remember we had indicated -3 here. 2, -3 would be somewhere here. And we confirm that it is a minimum because it's a positive value. So it will turn this way. So we have the y-intercept, the x-intercept, and the turning points. So we do just the connection. So we have this, the curve will go this way, it will come this way, turns there. The other turning x-intercept is at a half, and then at y-intercept half. This is the sketch that is required from the question that we had. So thank you so much for watching, and for your audience. I request you, if you haven't subscribed, please subscribe, and if you have, make a comment, give me a like, and you can share this. Be free to share this knowledge with your friends. Thank you for your audience once again. I don't take it for granted that you could spare time to listen and to watch what I'm doing and presenting to you. Bye bye, and always take care.